quicker than the texture of space-time, can stay aware of it and it'll simply tear. I'm scared by this right now. Our night sky is changing quickly and in simply a question of many years in the event that not years it could turn out to be totally unrecognizable. Cosmologists overall are sounding the caution. Specialists like Neil deGrasse Tyson have as of late affirmed the unavoidable blast of Polaris, and the tale behind it is very terrifying. Polaris, known as the North Star, has for some time been a consistent in our night sky, filling in as a vital reference point for stargazers, pilots, and cosmologists. Anyway, this could before long change, modifying our night sky and galactic estimations endlessly. We should dig into the meaning of this danger and its suggestions for us all. Go along with us as we uncover the narrative of Polaris as it moves toward its end. For quite a long time, Polaris has directed sailors and space experts the same, standing firm on a love footing as a directing light. Its relentless presence in the night sky has been fundamental for route, yet this strength may before long be upset. In September 2023, an exploration paper introduced by the regarded illustrious cosmic culture cast uncertainty on the destiny of this divine illuminator. Polaris is near the precarious edge of detonating, possibly disappearing from the night sky perpetually. Before we investigate the results of this disclosure, how about we see more about Polaris, otherwise called the North Star or Pole Star? Polaris is extraordinary because of its vicinity to the heavenly North Pole. Arranged straight over Earth's North Pole, it shows up practically fixed in the northern sky, found in the heavenly body Ursa Minor, or the little scoop. Polaris sparkles as a reasonably dazzling yellow white, very monster star, a lot bigger and more brilliant than our sun. It's anything but a singular star, yet part of a complicated triple star framework, with Polaris N and Polaris B framing a double pair, while Polaris B circles around them. The collaborations among these stars make gravitational powers, molding their circles and impacting their conduct. Any disturbances in these cooperations can prompt unpredictable varieties in the star's splendor or throb designs. Anyway, the specific components behind these communications stay muddled. Polaris is found roughly 323 light-years from Earth, meaning the light we see from it today kicked off its excursion more than 3 centuries prior. Consequently, if Polaris somehow managed to detonate now, we wouldn't notice it until more than 3 centuries after the fact. It's even conceivable that Polaris has previously detonated, and we're yet to observe the light from that occasion, since forever ago the North Star has held colossal social, navigational, and emblematic importance. Its solidness and fixed position made it a priceless guide for old guides directing them across oceans and grounds. Emblematically, Polaris addressed steadiness and direction, staying resolute in the midst of the ever-changing night sky. For stargazers, Polaris filled in as an essential reference point supporting the investigation of divine movements in factor stars. As a state variable star, its intermittent varieties in splendor have given important experiences into heavenly properties, and the idea of variable stars, this trademark, likewise assumed an urgent part in deciding enormous distances and adjusting instruments. These throbs follow an anticipated example, which has been the standard for the star, making it simple for us to expect its way of behaving. Anyway, as of late, Polaris has wandered from this normal way of behaving. This anomaly in its throb cycle has confounded cosmologists, prompting a nearer assessment of this divine peculiarity rather than its standard. Unsurprising example, Polaris has started showing flighty patterns of diminishing and lighting up. Researchers are currently bringing up in worries that the star might be moving toward the finish of its life this lines up with, ways of behaving commonly saw in stars. Approaching their end, for example, the continuous extension of least throb period, which was once steady this can be, credited to connections inside its star. Framework we've noticed a yearly expansion in the throb term of 4.5 seconds, which could appear to be irrelevant yet holds critical ramifications. A few space experts propose that gravitational communications between the polar AR stars could be causing these vacillations in its air conditions, straightforwardly influencing its throb designs anyway. Others are more frightened, accepting that similitudes among Polaris and creepy crawly Jew recommend the star is near the very edge of detonating. The likenesses between Harari's way of behaving and that of Bug Jew's one more prominent star in the Orion heavenly body are striking. The two stars have shown confusing anomalies in their radiance, raising worries about potential blast stars in their dusk. Organizers frequently display such anomalies prior to arriving at the climax of their life cycles, while NASA has communicated elevated worry about Scarab Jew. Comparative consideration hasn't been authoritatively coordinated toward Polaris yet. As a sage star approaches the finish of its life cycle, it advances through different stages, including the principal succession stage, red monster stage, and at last the cosmic explosion blast. In view of Polaris sporadic throbs, researchers anticipated it has entered the phases of helium exhaustion, regular of seat stars approaching their end. These inconsistencies in Polaris' way of behaving line up with designs characteristic of Sate stars in their dusk stages, yet conclusive signs of its approaching cosmic explosion stay. Uncertain space experts are perseveringly dissecting these inconsistencies to figure out Polaris' destiny. If Polaris somehow managed to go cosmic explosion, it would probably be a fabulous occasion in our sky, possibly surpassing the moon and becoming one of the most splendid items apparent for days, weeks, or even months. Its appearance could radically change, briefly modifying our impression of natural star groupings, like the Large Scoop or Urim excavator, of which Polaris is a section of. Confidence the Earth would probably be entirely protected regardless of whether Polaris were to detonate, given its mass and distance from us, while a Polaris blast probably won't be really that outwardly stupendous of Bug Jews. It may as yet be apparent to the uneye for a drawn-out period. An eclipse close by, stargazers and observatories would, without a doubt, pay heat, igniting interest inside established researchers and among stargazers overall. Anyway, the particular perceivability and effect on Earth's environment or environmental elements would be less huge, contrasted with a nearer cosmic explosion occasion. Yet, what might be said about Polaris itself? What will be its destiny after a potential cosmic explosion occasion? How about we explain one thing? While monster stars normally end their lives with the cosmic explosion, this is probably not going to be the situation with Polaris. When a monstrous star goes supernova, it typically undergoes a violent explosion, releasing a tremendous amount of energy, and the core may collapse into a neutron star or a black hole. However, Polaris is not classified as a massive enough star to undergo such a dramatic end. Instead, it is more likely to evolve into a red giant before shedding its outer layers and leaving behind a white dwarf, a dense remnant of the star that no longer undergoes fusion. This process would result in a gradual fading of Polaris over time, rather than a sudden spectacular explosion. The fate of Polaris, while still uncertain, suggests that we might not witness the kind of dramatic cosmic event we might expect from a larger star. Instead, we would see a slow transformation, with the star's luminosity diminishing as it sheds its outer layers and its core cools down. If Polaris does eventually go through this transition, it would likely no longer be the bright guiding light we've come to rely on for navigation and stargazing. However, it would still hold immense scientific value for astronomers. The study of its final stages could provide critical insights into the life cycles of stars, especially those with similar mass and characteristics as we observe these changes in Polaris. We would continue to gain a deeper understanding of stellar evolution and the forces that shape the universe. For now, though, it remains to be seen whether Polaris will truly meet its end in the near future or whether it will continue to shine in the night sky for many years to come. Regardless of its fate, the star will always hold a special place in human history and culture, having served as a celestial guide for millennia. The eventual transformation of Polaris will be a reminder of the ever-changing nature of the universe, a universe where even the most constant and familiar elements are subject to the passage of time and the forces that govern the cosmos. Cosmic explosion, a gigantic blast happens inside it, denoting the last calamitous stage in its life. This interaction includes a total breakdown of the center, setting off an extraordinary shock wave that makes the star detonate viciously. Anyway, Polaris isn't sufficiently enormous to go through such a blast. Rather, when Polaris debilitates its atomic fuel, it will shed its external layers and change into a white dwarf. This change won't bring about a cosmic explosion, but instead a tranquil end as it develops into a small, very thick, heavenly leftover. A white dwarf is the remainder of a low or medium mass star that has depleted its atomic fuel. It's unbelievably thick, probably as massive as the sun, but packed to the size of Earth. When this happens, we can never again see its leftovers from our planet, similar to how we notice the star today. Contrasting the expected impacts of Polaris overflowed with verifiable cosmic explosion events gives important insight into the development of stars and their definitive destinies, contrasting our assumptions and irrefutably factual supernova like SN 1054 or SN 1987A and later events. For example, SN 2011 Fe or SN 2014J gives important information to understanding the possible fallout of Polaris burst. SN 1054, for instance, brought about the arrangement of the Crab Nebula, a cloud that continues to extend and produce radiation across numerous frequencies, offering cosmologists a rich field for study. Correspondingly, SN 1987A observed in the Large Magellanic Cloud gave insights into the cycles of nucleosynthesis and the elements of cosmic explosion, remnants analyzing peculiarities. For example, the formation of nebulae, the release of grandiose beams, and variations in iridescence can offer insights into Polaris' unique qualities. The formation of nebulae like the Crab Nebula results from the removal of material during the cosmic explosion blast, which interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of heavenly birth and death. Furthermore, the release of vast beams, high-energy particles advance quickly by cosmic explosion shock waves has implications for astrophysical cycles and vast radiation conditions. To make a conclusive correlation, researchers assess differences in mass creation and speed of shot-out materials between Polaris' expected burst and other observed events. This includes studying the light curve spectra and remnants from these events and extending similar attributes for Polaris' expect burst, evaluating whether Polaris burst could lead to the formation of nebulae or distinct chemical distributions improves our understanding of its potential. Results. Another crucial area of examination involves assessing the rotational fluctuation of stars, approaching their end stages much like Polaris against observed cosmic explosion forerunners. This relative investigation can help check similarities or deviations and provide insights into the burst mechanism, pulsational variability in stars approaching the end of their lives might be characteristic of internal threats or looming catastrophic events, offering hints to the transformative processes leading to cosmic explosion blasts. Despite meticulous observations and extensive analysis, space experts find themselves puzzled by the anomalies observed in Polaris behavior, unraveling the unique circumstances driving these anomalies holds the key to advancing our understanding of stellar evolution. Understanding the mechanisms responsible for Polaris sporadic throbs requires interdisciplinary collaboration and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a critical reference point in the night sky presents significant concerns for galactic endeavors. Ground-based telescopes and divine estimations would require recalibration, affecting the precision of cosmic evaluations. The absence of Polaris could also affect navigation systems and cultural practices dependent on celestial landmarks, highlighting the importance of this cosmic event. The mysterious behavior displayed by Polaris highlights the significance of observing heavenly phenomena and fostering collaboration to resolve questions surrounding star evolution. Polaris' future remains dubious, but it serves as a powerful symbol of the ever-changing nature of our universe. While its ultimate fate remains shrouded in mystery, the study of stars like Polaris expands our understanding of the universe and its immense, unusual nature. Whether we witness Polaris' emotional end or not, its legacy as the North Star will undoubtedly leave an enduring imprint on mankind's history and our exploration of the stars. As scientists continue to monitor Polaris, they are also developing new methods and techniques to predict and understand the behaviors of stars approaching the end of their life cycles. The ultimate goal is to gain a better understanding of stellar evolution and the various paths stars can take as they age. This includes refining our ability to predict when such astronomical events as supernova could happen. The study of Polaris anomalies adds a pivotal part to the riddle, offering new insights into how stars behave as they approach their final stages in the broader context of our solar system. The fate of Polaris has implications for how we view the universe as a whole. The stars that light up the night sky are far more transient than many of us realize. While Polaris might seem like a constant guide to us, in reality it's only one of countless stars, each on its own journey. The possible transformation of Polaris, whether it fades quietly into a white dwarf or detonates dramatically, mirrors the life cycle of many other stars across the universe. In a way, the tale of Polaris reflects our own curiosity and quest for knowledge. As we look up at the night sky, we often seek stability, something to anchor us in an otherwise chaotic world. Yet the universe is far more dynamic than we can ever fully comprehend. Stars like Polaris remind us that everything, even the most stable parts of our sky, is constantly changing, evolving, and eventually fading. For now, as cosmologists continue to gather data and refine their models, we may have to wait to witness the end of Polaris. It could be years or even hundreds of years before the true nature of the stars' demise is revealed. But rest assured, astronomers will observe closely the inevitable transformation of Polaris. Whether as a quiet fading or a magnificent explosion, will leave a permanent mark on how we understand the universe and the forces that govern it. While we may never live to see the last, moments of the North Star, the legacy of Polaris will undoubtedly continue to inspire generations of scientists, astronomers, and visionaries, whether it dims out of view or explodes in a brilliant burst of light. Polaris has already earned its place in the history of cosmology. It has been a guide for countless explorers, a marker of time for ancient civilizations, and a symbol of eternity in an ever-changing sky. The fate of Polaris may be uncertain, but its role in our story is clear, and as we focus on the stars, pondering the mysteries that still remain, we can hardly imagine what revelations await us next. The universe, as vast and cryptic as it may be, will continue to unfold its mysteries one star at a time. The unfolding of these mysteries is a testament to the endless curiosity that drives humanity to look beyond our planet, seeking answers to questions that span the cosmos. Every star, every planet, and every galaxy represents an opportunity to expand our knowledge of the universe, offering new clues about its origins, structure, and the forces that shape it. As we learn more about Polaris and other stars like it, we may uncover secrets that transform our understanding of time, space, and even the very nature of existence itself. The study of stars nearing their end stages, like Polaris, also highlights the interconnectedness of cosmic events. The death of a star is not just the end of one celestial body. It is a key moment in the larger cosmic cycle that includes the formation of new stars, planets, and even life. The materials dispersed by cosmic explosions, for example, enrich the surrounding space, providing the building blocks for future generations of stars and planetary systems. The very elements that make up life on Earth were once forged in the hearts of long-dead stars, and understanding their life cycles helps us appreciate the intricate processes that sustain the universe. Moreover, as technology advances, so too does our ability to observe and understand these phenomena in greater detail. Telescopes and instruments that can peer deeper into space are being developed, allowing us to observe distant stars at different stages of their life cycles. With this new technology, we may one day witness the dramatic transformation of Polaris, whether in the form of a graceful fading into a white dwarf or a breathtaking supernova. The more we study, the closer we come to understanding the fundamental processes that govern the life and death of stars, and by extension, the evolution of the universe itself. In this way, the study of Polaris and of stars in general serves not only to deepen our knowledge of the cosmos, but also to inspire us as we continue our journey as explorers and thinkers. The legacy of Polaris, whether it eventually fades quietly or explodes in a burst of light, will undoubtedly be felt for generations to come, shaping both the future of astronomical discovery and the way we view our place in the vast universe. As we continue to gaze at the stars, we are reminded that the universe is a dynamic, ever-changing expanse. Each star, no matter how distant, has a story to tell, a story of birth, life, death, and transformation. And in the case of Polaris, that story is far from over. The North Star may one day fade from view, but its legacy will live on, lighting the way for those who look to the heavens for answers, and for those who seek to understand the mysteries that remain in the vast, uncharted expanse of space.